Hello and welcome back for more office hours with Bill Jennings with Klamath Community College, Distance Learning in Mathematics. We're on our fifth video of a series of 5 talking about solving quadratic equations, and we're on this last piece right here for the quadratic formula. You could call it the universal tool for solving quadratic equations. Isn't always the most efficient if something factors quickly or can be manipulated very fast to make it used for the square root method. But one thing's for certain, if you plug numbers into this formula, it will give you the answer every time. Sometimes it's a little bit of work cleaning up the radicals, but we can get there every time. So quadratic formula is derived by completing the square against a generic quadratic equation of ax squared plus bx plus c equals 0, and it comes from that place. So in order to plug numbers into the quadratic formula, you have to start off with an equation that is in exactly that form. Some number times x squared plus some number times, or bx in that case, and some number is the b, plus some constant. Any of those could be zeros or negative numbers. You could, if you were really wanted to really work hard, you could let those numbers be fractions, but much cleaner if you have fractions. Just multiply it, the denominator out, so you have all integers, and you'll find it to be plugging into the quadratic formula much cleaner for you. I would never recommend to plug a fraction in. Just simply multiply out the denominator and make that be an integer value. So that's our strategies. Set it up into this form of ax squared plus bx plus c. Identify the values of a, b, and c. Watch out for negatives. They can be negative. And then plug it into our formula, which I presume you probably have seen someplace before in the past. Resort that one to memory, and we'll be in good shape. All you really have to do is write the formula down every time you do one of your homework problems, and you'll have it down just pat. Then we want to reduce our fractions after we pull out and reduce our radicals, reduce our fractions, and remember that this is actually producing 2 answers because of that plus or minus living out in front of that square root sign. So let's see if we can identify how this comes together. So this one is set up for us very well because remember, it had to be in the form of ax squared plus bx plus c equals 0. We said it's got to start like that, and then you can go with it. So in this case, a is going to take on a value of 5, b is going to take on a value of 1, don't let that one fool you there, and then c is going to take on a value of -2. Now the one you kind of got to be careful of is when the b takes on a negative value. You'll see in the formula you got this negative b and a b squared, and things happen. My next example, that's going to happen. So our quadratic formula says x equals the result, x at the end of the day, is going to be a negative b plus or minus the square root of b squared minus 4ac all over 2a. Wherever I see the variable, it's just time to plug in my numbers. So x equals a negative b. Well, b was told to me to be 1, so it's going to be a -1 plus or minus 1 squared. If it was a negative, be very careful about where you put that negative. Then we end up with a -4. And then a was said to be 5, and c was said to be -2. Now make sure you extend that radical sign out so we get everybody covered. And then 2 times a, which again was said to be 5. Now it's just a matter of arithmetic, reducing a radical and reducing the fraction if it does. So this turns into a -1 plus or minus, well, this is going to be 1, and this is going to turn into a plus, because that's going to really be a 4 times 5 makes 20, and then 40, and so I'm going to call it 40 altogether, because they multiply together, and I've got this negative here and negative there. That's going to make the result come out to be positive all over 10. At the end of the day, it looks like I've got my answer right here, a -1 plus or minus the square root of 41 all over 10. Now, if that radical can be reduced, we'd want to start factoring it and pulling numbers out in front of the radical. And then if there was a common factor here and here, we could pull that common factor out so I could try and divide it out with the 10 and make a reduced fraction. Now up here, let's take a look at this question. I've got 3x squared equals 2x minus 3. Now I cannot do anything with this equation until I put it in the form of ax squared plus bx plus c equals 0. I have to manipulate this right off the bat to make it look like this. Now it's a negative 2x because I have to subtract 2x from this side to make that 2x go away, and then I'd have to add 3 to this side to make that happen on this side of the equation. So I end up with, I got a little typo there, let's fix that, equals 0 on this side. Now, one could say, that's a good time to think, well, we're actually being asked to solve it by the quadratic formula, but it'd be a good time to ask, is it factorable? Because if it's factorable, I don't need to plug it into here. And that's like I said at the beginning, that sometimes we can start getting conditioned and that we're going to use the quadratic formula all the time. And sometimes if it factors very quickly, let's just factor it and be done with it. We don't need to waste our time with it. But in this case, it doesn't factor, and I'm trying to exercise the quadratic formula. So again, A, B, C, that's where they live. So in this case, A is going to take on a value of 3, B is going to take on a value of negative 2, and C is going to take on a value of 3. Now it's time to plug it into the formula. X equals a negative B plus or minus the square root of B squared minus 4AC all over 2A. Like I said, if you do your homework and you write that quadratic formula down every time in the course of doing your homework, you're going to resort it to your memory and you're going to be just fine. What I want to talk about real quickly here, though, is this negative b. I said it's a negative b. Well, b is a negative 2. So when I plug in that negative, it's going to be x equals a negative 2. That's going to take on a value of a positive 2. Some of you will catch on really fast with that and just put that plus 2 in there. But don't be afraid to show your work a little bit there. Over the square, or time, plus or minus the square root of b squared. Now, who's getting squared here is the value of b. And in this case, b is taking on 2. So that's a negative 2 squared. And that negative 2 is inside that square, so it's going to end up becoming a positive 4. Minus 4 times A times C, which is 3, all over 2A, and 2 times 3. Let's see what we've got going on. Well, this negative 2 turns into 2, plus or minus the square root of 4, because that's the negative 2 that gets squared. And in this case, this is going to turn into 9 times 4. It looks like 36, all over 6. Now, one thing to kind of look out for here is this 4 minus 36. I see a negative number coming. It's okay. That's going to give us this imaginary answer. Now, this b squared minus 4ac that lives inside the radical has a special name. It's called the discriminant. Because if b squared minus 4ac evaluates to a negative number, you're going to get imaginary answers. And you're not going to get just one imaginary answer. You're going to get 2 imaginary answers because of the plus or minus out in front of the radical sign. If the b squared minus 4ac makes a really cool number like 25, 49, 64, those are nice square numbers, and so that's actually going to, then you could have factored it because the radical is just going to simply disappear and you're going to get 2 rational answers because the radical goes away. Now, if it turns into being a not so cool number like 31 or 35, you're going to end up with an irrational answer because the radical is going to live along, like this 41 that we had going on over here. We're just going to have a radical, we get an irrational answer at the end. In this case, we're going to get an imaginary answer on the one we're working on right now because of the negative value that came out of it. So this turns into 2 plus or minus the square root of 32. Get that going on there. 32 all over 6. It would be negative 32. Almost lost my imaginary number there. Negative 32. Well, let's see if we can deal with that. What is a negative 32? Could we factor it, then pull some kind of a good number out of that? I think that 32 has some good things going on. I think that 32 is the same thing as 16 times 2. So we could say this is 2 plus or minus this, kind of like 16 minus 2 all over 6. And so that 16 is going to come out as a 4. So I end up with 2 plus or minus 4 square roots of negative 2 all over 6. Right now is when I want you to be very careful about reducing this final fraction. So I did a good job of taking my radical and reducing my radical, or simplifying my radical, and now it's time to reduce this fraction. Be very careful about, I know some people like to start drawing lines through things. We don't reduce fractions by drawing lines through things. We reduce fractions by factoring. And we can factor the top with a 2 in common, 1 plus or minus 2 square roots of negative 2, and the denominator has a 2 in common with that 3, and so then I can just keep this going on, and now this 2 over 2, because it's in a factored state, I can cross those out. It actually reduces, and I end up with a final answer of 1 plus or minus 2 square roots of negative 2 all over 3, and there's my final answer. Again, 2 answers, both of them imaginary, and we're off and running. Let's see if we can't go to the next page and just talk about some strategies on how we could potentially identify which strategy will work best. So remember, we've gone over factoring, square root method, completing the square, and quadratic formula. Completing the square, remember, is just an extension of the square root method, that if we see something quick, we can just maybe make a quick modification and make it square root methodable right off the bat. So if I saw 2x squared minus 27 equals 0, I would be looking at this and I'd be saying, well, is it possible that I could make it look like something squared equals a number on the other? Now this one's kind of hiding in the weeds. I only have an x squared. So I could simply say, well, let's just get the x squared all by itself on one side. I could take the equation and I could say, well, that's 2x squared equals 27, which then is x squared equals 27 divided by 2, and I could apply the square root method right here. And I would then say, okay, x equals plus or minus the square root of 27 halves. I've got a little bit of simplification to do, but it's really looking at me like, hey, you could just use the square root method here. If you didn't see that, you could try and factor it. It's not going to factor very well. If you try and do the completing the square, it's going to be really a nasty one to work with. But could we say that this is really 2x squared plus 0x minus 27 equals 0, and could identify a being 2, b being 0, and c being a negative 27, and plug it into the quadratic formula? It would certainly work. Now, on this one here, I have 8x squared plus 18x minus 5. Now, depending on your comfort level with factoring, maybe this is something that you see and you say, well, you know, I think I can factor that. Some people aren't very strong at factoring, and that's okay. But also remember that if you start saying a equals 8, b equals 18, and c equals a negative 5, you're going to get a very large number when you do b squared. But then it really, at that point, is a matter of just hanging on to numbers in your calculator, because it will run through. In this one, the easiest way would have been factoring. It would factor, and you would recognize it as being factorable when you found your discriminant, b squared minus 4ac, to come out to be one of those really cool square numbers we were talking about a minute ago. Last one, 5x squared plus x minus 2. I could try till the day is long to try and factor that, and I don't think it's ever going to work out for me. And then I could also look at it and say, well, maybe I should apply completing the square. But this 5 out front is going to make a lot of extra work that maybe I don't want to deal with. By the time I'm done thinking about it, I think if I just identify a equals 5, b equals 1, and c equals a negative 2, I can just plug this guy right into the quadratic formula, and the answer is going to just work itself out once I've worked through the arithmetic of it. Hope you enjoyed the series on solving quadratic equations, and we'll see you on the next video.